Hello, this is the first part of the Module 11 lecture. And in this module, we're going to learn to perform what is called simple linear regression analysis. The learning objectives for this module is that by the end of it, you should be able to explain what regression analysis is. You should be able to calculate and interpret the least squares estimates of the intercept and the slope for the regression model. You should be able to calculate the standard deviation of the errors and the coefficient of determination. Also, you should be able to perform a test of hypothesis about the slope parameter and interpret the results of this test. You should be able to explain what linear correlation is, calculate the correlation coefficient, and use it to test the hypothesis about the correlation coefficient for the population. And of course, be able to interpret the results. Also, you should be able to make predictions using a regression model and calculate the appropriate confidence interval around those predictions. And of course, interpret those confidence intervals. And finally, you should be able to explain what are the assumptions of regression analysis and explain how they are verified. So we're going to learn all of this by the end of Module 11. So we're going to start with section 13.1 in your textbook. And in fact, this simple linear regression corresponds to what is covered in chapter 13 in the textbook. So let's talk about simple linear regression. To do this, I want to start with an example that I think is familiar to you if you have taken algebra, or maybe even back in high school. You remember that you had you learned to work with the equation of a straight line. Typically the equation is y equals to mx plus b. In here, I'm writing the equation in the way that we're going to use it in regression analysis, where y is the dependent variable, x is called the independent variable, a is called the intercept or the y-intercept, and this is the value of x, or rather the value of y when x is equal to 0. So it's shown right here is where the line intersects the vertical axis, right at x equals to 0. And b is the slope, that is the change in y per unit change in x. So this little triangle here is showing you how much the line is rising, and that rate of rise is called b, the slope. Also here we're showing this equation and the arrow means that this equation describes this straight line. Now this equation, we call it we say that this is a deterministic model because once because a and b are known, I should say, and then for any value of x, you can calculate exactly the corresponding value of y. Here's an example of this. When I first came to the United States, I came from Mexico, where all the temperatures are given in degrees Celsius. So when I came here, I had to use this formula to change the temperatures in degrees Fahrenheit to degrees centigrade so that they will make sense to me. So this is an equation of a deterministic model, because for any temperature, using this equation, any temperature given in degrees Fahrenheit, I can find the exact temperature in degrees centigrade. And I could reverse this equation and find for any temperature in degrees centigrade, I can find the corresponding degrees in temperature in degrees Fahrenheit. So this is an example of a deterministic model. So we're given the equation and we use the equation to go from from a temperature in a given scale to another temperature in a different scale. Well, in regression analysis, things are differently. Even though we're working with that equation, the approach for regression analysis is very different. So here, typically a researcher knows of some dependent variable, and this researcher suspects that some independent variable affects the dependent variable. But we don't know exactly what is the relationship between y and x. So again, y is the dependent variable, x is the independent variable. And so in order to assess the dependency between x and y, the researcher collects data on Y and X simultaneously for each. They set X at a certain value and see what the Y value is. They set X and another value and see what the Y value is. So they collect this data, and then they use regression analysis. And then first they select the linear model. They calculate the coefficients for the model, the intercept and the slope. They determine if these coefficients are statistically different from 0. And they use the errors between the observed values and the values predicted by this regression model to assess how well the model represents the data. So in here, the problem is backwards, if you will, because we suspect something, we collect data, and then we think that the relationship between X and Y follows that model of a straight line, and then we go about using the data to calculate the slope coefficient and the intercept. And then we determine if the model is appropriate for the data and if these coefficients are statistically important. So we're going to learn how to do all of this in this module. And here's an example. So we have a student that has an off-campus job, and this person works 8 hours per week. And this student is thinking of working now 16 hours per week, but the student is worried about the impact of working more hours per week on his GPA. So to try to figure out how to help this student make a decision, we went to the Department of Institutional Research at UIW, and they gave us this information for 10 students. So we have the hours worked per week in this column and the corresponding GPA. So the question is, well, how can we use this information to help this student make a decision based on how much his GPA will decrease, or maybe it doesn't decrease at all? We don't know. So we're going to use this data to find that out. And the very first tool we use in regression analysis is what is called the scatter plot. The scatter plot is just a graph that shows a relationship of two continuous variables. So in this graph right here, we have GPA, which is the dependent variable, because the GPA depends on how many hours the student works. So the hours worked per week is the independent variable. So we graph this variable and we see if there is a relationship between the two variables, and also if we can use a straight line to represent the behavior of GPA with respect to the hours worked per week. And so that's the first thing we need to do. In your homework, I know that you have a problem where you have data like this. They give you data in a table like this, and they ask you to construct the scatter plot. So you can construct this scatter plot by hand, but my suggestion is to use Excel. It is good to learn to use Excel. You're going to use it in your work in the future. So the first thing to do in Excel, well, I have the instructions here. You can find the data set in the Module 11 folder, or module, I should say. But let me switch over to Excel and let's see how we do this. Let me see here. All right, what I've done is I have entered the data that is given to me. All right, so to construct a scatter plot, the easiest thing is you can either click and drag to select the data. If you don't like that, you can do Control A, and that selects the data. Then you can go to, let me make this thing a little smaller so it fits into the screen. All right, so let me make this a little bigger. All right, so now we're there. So let's click on this Insert tab up here. Click on it. And then you see these recommended charts. So click on that. And then it gives you options of multiple charts. We want the scatter plot. So click on it. And here's the graph. And one important fact to remember is that the first column corresponds to the X variable, and the second column corresponds to the Y variable. If you reverse them, the graph will be switched. So, and again, you can use this, when the graph is active, you see this plus icon, and you can click on that to level your axis, or you can click on that to add a trend line, in this particular linear trend. So I'm going to click on it. And so there's your scatter plot with your line. But always please include that title axis. So in the vertical axis, that's a white variable, so that will be GPA. And in the horizontal axis, that will be the hours per week. Okay. So there is the graph. So again, you can use Excel to do your homework. Very easy to do. Not only that, then you can do this in the future. All right, so here are the instructions for how to do this scatter plot. And also now continuing with our discussion, picking up on the last question. So, well, can the relationship between GPA and hours work be represented by a straight line or a simple regression model? And that's what we did in Excel. We asked Excel just to draw that straight line, and it's using regression analysis to do this. And here's the line. So the question says, well, do you think that GPA decreases linearly? In other words, following this straight line as the number of hours per week increase. And I would say it seems to be. So it seems to follow a straight line. Not exactly, but it seems to be follow a straight line model. And it might be appropriate for this. So we're going to go with this idea and continue on and learn how to fit this straight line model to the data. And then we're going to learn how to predict with this model so that we can see what happens to GPA when we go from working 8 hours to working 16 hours, and see how we use this model. All right, I'm going to stop the recording here. In the next part, we're going to start talking about regression analysis.